All right, everybody, we're going to go ahead and get into today's or this week's, I guess, bonus lecture. We're going to be talking about the design process as kind of a holistic system. I'm hoping that this is mostly a review, something that you saw in the CAD course or in Engineering Design Society if you've taken that already. But we're going to go ahead and jump on into it. So this is we want to call this our process flow chart. That goes through and kind of describes the entire system that we are dealing with. Right now, I've broken it up, kind of color coded it to show the different how this relates to DML and the different parts of the class. So normally in the real world, this section right here is one of the first tasks of a design engineer, figuring out something that's needed, going through and defining the requirements. We're going to talk a little bit more about that on the following slides. But for right now, we just need to understand this is what I've given you in part. Half of this and these portions right here fall into DR1, Design Report 1, which is the first major assignment in the course. When I say I've given you requirements and then I've defined them, I've partially defined them. However, there are still some things that you're going to need to go and define on yourself. Again, more on that in a second, but everything here, and we'll say half of defining the requirements is a part of DR1. Down selection, picking which design is going to be the best design to meet these requirements. This is DR2. And then the finalizing, for DML, we are not going to be validating. There's not enough time in the semester to prototype and test designs, but we are going to finalize designs and figure out manufacturing plans, et cetera, et cetera, et cetera, in DR3. And then the final step down here, again, something that we are not doing in this course, would be bringing a product to market. And of course, the screen glitches out. There we go. So bringing a product to market, that's not something that we're going to be doing for this class, but it is something that would be the final step of the design process. So let's go ahead. We're going to jump in looking at these first two steps, identification of need and defining our requirements. These are, I guess we will call this our problem statement when it comes to the design process. So if we're going to be looking at this as a problem statement, we have a lot of things that are going to feed into the identification of need. Might be something a sales guy said. It could be a production problem. It could be from marketing. Let's see, what else could we have? Grandma can come up with something. There's a million different things that will go into figuring out what the needs are. It could be a problem in the community. Like I said, a lot of different things are going to say, hey, there is something that I need. There's a problem that I have. There is something missing that would make my life easier, et cetera, et cetera, et cetera. So we got to come up with what our problem is first. And that is the first step of the design process. In the middle here, this pathway right here in the middle along this process is going to be doing some research. Background research on what the need is, what the actual problem is, understanding it more holistically. And all of this research is going to feed into our requirements. Requirements are best described as quantifiable metrics. If we go and we apply this to DML, and we apply it to something like the slicers that you are being told to design for this design project, I've said you have a need. That need is for your course. So let's go ahead and add in another thing that can feed into the need. Your professor said something. All right, that's me in this case. So we're going to be looking at this. One of our metrics that we're going to have, for example, for DML is our slicer displacement. In the requirements, I give a general statement about how long, about what the slicer needs to be able to cut. You have to then go and do your research to figure out what that displacement is actually going to be and what the quantifiable metric for that is. There are other things that I gave you that are pretty already quantified. Cost is already been quantified. I gave you definitive example or definitive rule on what your cost constraints are. For everything else, we're figuring out what the quantifiable metrics are going to be. What are the things that go into evaluating our design, or I guess how design will be evaluated is what our requirements are. And again, most of the time, these are going to be quantifiable, meaning that they have numbers put to them. All right, so zoom back out now, and then we can go ahead and take a look at after we have our metrics. So we have coming in here, we now have our quantified requirements coming into our design, and now we have to generate our concepts. Generating concepts, and this will be a lecture for next week. Generating our concepts, we have to go and say, okay, cool. What functionality do I need? What mechanisms get me that functionality? What parts build those mechanisms? And then we can assemble into our concept. All right. And then once we have our concept, we're going to go down and we begin to analyze and refine. This analyzing step, our analyzing step, feeds back into our quantitative or our quantifiable requirements. Hey, I've got to do some math now to make sure that this concept is going to meet my requirements. If it doesn't meet my requirements, if it's got an X there, then we refine. And then we analyze again. And we start working on taking our concept through this loop. Going through this loop time and time and time again until we make sure that down here, this outlet right here is that my requirements are met. All right, we keep on doing this loop until we can escape it, making sure that our requirements are met. This does not mean that your design is the best design, your concept is the best concept. This doesn't mean that your concept solves every problem. Our requirements are met here. This means design will work. All right, that is it. That is all we care about at this stage. We have a concept and it will meet the requirements of the design. It will work. My favorite thing to say at this point is perfection is the death of finished. If you keep on trying to refine and trying to get something finished, you will never be done. You need to make sure that it is complete enough to meet the requirements. And at that point, maybe a little bit more refinements to tweak things, make it more aesthetic, whatever, but it's time to keep on moving on down the line with our design process. If you cannot refine this thing to get it to work, then we have our other loop is right back into generating more concepts. If our concept doesn't work, or it can't be refined, we loop back in and we come up with another concept. This is not bad. There's a big hesitation a lot of times in design to keep on going. I've said this before many times, and I'll say it again many times. If you keep on polishing a turd, you're just still going to be left with a piece of shit. So really at this point, kind of need to get to a point, okay, cool, I've refined this a little bit. There's no way I'm going to meet my requirements. Eject, come back around, come up with some other concepts, come up with some new ideas. Or even better, have 3 or 4 concepts that you're kind of refining in parallel, and you go, ah, this one's the one that I like the most, that's got the most potential, and you feed that one forward into the rest of the design process. All right, once we have a concept that works, we're going to bring it down into the down selection. So at this point, we are going to have coming in many concepts. All right, at this point, we're going to go ahead and put a little red asterisk up here. This is where it gets to being a big group project. Everybody in the groups come up with um, their own little concepts, and we are now going to be comparing them. And our output here, what we want here is the best design for our requirements. That is what we are hoping to get out of this process at this stage, is what design is going to be the best one to move forward with. What concept is going to be the best one to move forward with to work on finalizing. How we go about doing that is with something called an evaluation matrix or a decision matrix. This is our tool that we are going to use for working on our, or for determining which design is. There's more things than an evaluation matrix that you can use. We use these evaluation matrices, these decision matrices in DML because they're very simple, they're very straightforward, and they help to really kind of lock in the quantification process, which is a very fundamental thing, not to make decisions. This is evaluation matrices are make decisions with numbers, not feelings. This is just one tool, but that is really what we are trying to do with these decision matrices. So what we're going to do is we're going to kind of break this decision matrix down the middle here, and we're going to look at the 2 parts of it. This side right here are my designs. This side over here is going to be my evaluation parameters. All right, so we're going to go ahead. Let's zoom in first, and we'll go ahead and take a look just at our evaluation parameters. All right, so what we have up here are 3 things. The first thing we have is our objective. Objective, this is going to be one of our quantified requirements. All right, this is going to be one of the things that we specified from our design problem statement, from our customer needs, from whatever that may be. These are going to be our quantified requirements. So these are going to be things that are used to, these are the things, better way to say this is, and I'm using the term objectives design must meet. All right, that is going to be our first thing that we are looking for. Typically, this needs to be done, or objectives, these guys need to be determined while you're generating concepts. So pretty much as soon as you are in your groups, you want to be meeting and discussing, hey, how are we going to evaluate all of our designs? Because we want everybody to be on the same page. The project statement says that there are 2 things that you are required to have. One of them is cost. The other one that you're required to have is time. The rest of the objectives in here are for you as a group to determine, how do we want to evaluate our designs? How do we want to come up with how we are going to assess and compare everything so we can compare our designs as apples to apples, not apples to oranges to pears to kiwis. All right, so we want to try and figure out how we can keep everything, have an even playing field for everything to be compared fairly. The next part of this is our weighing factor. This right here is something that oftentimes engineers try to fudge these numbers. And that's not, you want to tip the scales in favor of your design. It's your design, it's your concept. You say, hey, my design has the lowest cost. That means that I want to make cost be 25% of our valuation matrix, because that's going to give yours an incentive. That's going to be how it wins. We don't do that as engineers. We try and take out the emotion and the feelings about our design because we want to come up with the best design. And if we didn't come up with the best design ourselves, hopefully somebody else in our group did, and we can rally behind them and help support their designs. So our weighing factors, what we're going to have here to help figure these out is the binary trade study template. This is what we use for DML. Another option that could be done is everybody goes through and says, hey, this is the one I think is the most important. This is the one I think second most important. You put them in a ranked choice order, and then you kind of take how many points each one gets for each one of those positions, and you have some sort of a way of determining a weighing factor from that. We just use the binary trade study. It's simple and straightforward. That's the way how we do it. But essentially, this is saying the weighing factor is saying how important each objective is. How important each objective is to the evaluation. All right. And the third thing right here is going to be our parameter. The parameter, the best way to describe it is just the units that we are dealing with. What you can see down here is we have a bunch of units that are experience. And this is for a qualitative assessment. A qualitative assessment means a experience-based or a gut feeling-based method for doing it. It is something that we cannot put numbers to. For the purposes of DML, we are avoiding qualitative evaluations at all costs. Largely don't have enough experience to be able to qualitatively evaluate things. But also the point is to quantify different values that go into your design because quantitative evaluations carry the most weight. So we're going to be avoiding experience-based evaluations at all points. And we're going to try and find a way to figure out if we want to have something like reliability, for instance, as an objective, we need to ask ourselves how to quantify. How can we quantify reliability if that is an objective that we are going to feed forward into our design? All right, so this is the first half of our decision matrix. Let's go ahead and look in on the second half. So like I said before, this is all of our design evaluations side of our decision matrix. All right, we've got a couple of different things here. First thing is going to be our magnitude. This would be just the amount of that parameter. So if we were to remember from before, this line right here is cost. So for each one of these things, this is saying the first one, this cost is $2,500. This one is $2,500. This one is $2,200. All right, that's the amount of that parameter. for our score now, coming up next, this is our essentially a points rank for that parameter or for that objective. All right, what we do at this stage is we go and we say, all right, I have this score here, or this magnitude here, 2200. We say, all right, for my score, for determining a score, best value equals 10. All right, so we can see here, I've got the lowest cost gets a score of 10. All right, and then we're going to go and say, linearize to our best score. So that would say, so if we're going to be linearizing to our best score, that would just say, hey, $2,200 is to 10 points. Oh, didn't want to write that there. $2,200 is to 10 points. And of course, it doesn't come back. This ratio right here, 2,200 to 10, is equal to 2,500 over X. And this X becomes the other scores in the system by going through and doing that, by figuring out that ratio. So we go ahead and we linearize everything to get our scores. And then our third column, our value column, or actually I'm going to go and do that over here. Our value column is equal to score times our weighing factor from the previous portion of the decision matrix. And so we can go through and we say, all right, I got a score of 8.8. Cost was a 10%. That means it's 0.88, which rounds up to 0.9 for this situation. And we can go through and calculate what all of our scores are. And then we just sum up all of our scores to get a total score for each design. And we always want to take the design that has, we'll do this one in red even, that has the best score overall. This right here is my best design based off of the objectives that I specified when coming up with concepts and the cold hard numbers that went into determining what the magnitudes would be and what the scores would be for my design. All right, so that is both halves of the decision matrix. We can zoom back in now and take a look at after we have our final design, what goes on. This is our finalization stage. This is, like I said before, is going to be DR3. This is final drawings, final part and assembly drawings, finalized part and assembly, final drawings, a manufacturing plan, test plans, etc. At this stage, this is where all the detail work comes in. This might be where we start doing finite element analysis or detailed structural analysis for hand calculations to make sure that everything is going to be structurally sound and finalized in our concept. Our concept in our down selection was based off of initial analysis, not super and deep analysis. We want to find the best design holistically. Now that we have the best design, we're going to dive in and refine everything, super refine everything to completion. Again, not perfection here, but this is the next step. This is getting the design from 80% to 95, 99% complete. And then, as I said before, the finalize after this, we're going to go run tests, validate, make sure it works, make sure it meets my requirements, and then we're going to go on from there. Now, this is all done as a nice linear flow chart. However, that is not how this flow chart works in reality. There's actually a lot of recursive things. So I mentioned before that we kind of had the analyze and refine with a, hey, I couldn't get something that would work. There's my one loop. But we also have at the down selection stage, sometimes we have all concepts suck. And we have to go and come up with some new concept or come up with a concept that mix and matches the different parts of our design in there. Sometimes, as we are validating, we're going to notice a bug. And that bug can either become a feature or it can become new concepts because we have to throw out the concepts that we are currently working with. What you might also find is as you are defining requirements and doing your background research, oh, we're not even going to return back. We're going to eject completely from this loop. You might find that a solution exists. It's already out there. It's already good to go. It's all done. There's a million different recursive loops in this process that can get you. These are just a few of them, but by and large, design is iterative. And I'm going to write that up here. And I'll say it again and again and again. I say it in class repeatedly. It's not having to take something and scrap it and start over is not a step backwards. You've already taken 3 or 4 steps forwards. This is just a little bump in the road, and we have to keep on going and figuring out what the plan is along the way and running through all of these different recursive loops and iterative loops to make sure that we're getting concepts out that meet our requirements first and foremost. So we want to meet our requirements, and we want to make sure we're selecting the design that best meets those requirements so we can go forward with something that's strong. So when we finally do go and bring a final product out to market, we know that it's going to meet all of the needs that we established at the beginning, and that it's going to do it in a way that we are happy of and proud of, because that's what's going to be the best thing that we can have going forward and moving forward. All right, so that is real quick design process overview. That is all we've got here. So with that, yeah, happy designing.